Okay, now, inverse notation. I love how everyone's listening intently. All right. Okay, so just so you guys can see this, so f of x would be, so, and you could use a g of x or an h of x or something like that, but a lot of time they use f. So f of x would be your original, and they do it like, it looks like a little -1 power, but that notation is actually, and it's not just for functions, it's for matrices and some other things too. But that notation looks like a little -1 power f. You'd read that as f inverse of x is the notation for the inverse. So this you would read f of x. This would be f inverse of x. That would be how you would read that. Okay, now it depends on what you're given, how you're going to go about finding an inverse. So we're gonna do 3 types today. We're going to do if we have an equation, if we have a table, or if we have a graph. Okay, so if you have an actual equation, my first thing is actually going to be to encourage you to take it out of function notation, because I think that messes people up with the parentheses and everything. So I just wrote, if the equation is written in function notation, replace f of x with y, because it's the same exact thing. It's just, I think that notation is easier for people to work with. Once you do that, what you're going to do is you're going to switch x and y in the equation, and ultimately you'll solve for y. What that means is get y by itself. All right, now if you have a table or a graph, this is actually, it's kind of the same concept, but what we're going to do is just switch from the table the x and y coordinates. So the original equation, I don't know, like let me make something up. So like let's say I had the points, I don't know, let's say I had the point 1, 2, 3, 4, and I'm just making something up, 5, 6. So let's say those were my original points, right? All you would do for the inverse is literally, I should have made this line longer, sorry, switch those. So the inverse would be 2, 1, 4, 3, 6, 5. It literally just, you just switch the coordinates of the points. You don't introduce a negative, nothing like that. You literally just flip the x and y coordinates. I'm sorry, I should have made that line a little bit longer. Okay, now, for any inverse, the domain of the original is going to be the range of the inverse. And the range of the original is going to be the domain of the inverse. So the x's and y's flip, the domain and range also flips. So that's some way that you can check, especially if you have a graph, you can look at it. Okay, so we're literally just going to start out with a table. So how do I flip a table around? So pretend, if you don't like it, I know some people don't like the f of x notation, so I'm just going to, it's literally like an x and a y. So the coordinates would be, for example, -4, 3 would be a point, -2, 5 would be a point. So to do the domain, since we don't have a connected graph here, you would actually, they use these little things, they're called a brace. It's pretty much just like a squiggly line, but you literally just list the x values. So -4, -2, 0, 2. If any of them repeat, you don't have to list them again, but all of those are going to be different. To do the range, you literally just list the y coordinates of the points. And they do not have to come in any particular order or anything like that. I'm just kind of listing them left to right as they appear on the table. And they have like a little squiggly line instead of a bracket or parenthesis to let you know those are just individual points. Now, literally, all you have to do to find the inverse, you just take the y coordinates and they become the x coordinates. And then the same thing, I'm going to take the x coordinates and they're going to become the y coordinates. You don't flip which one they're listed with or anything like that. So I would just take the 3, 5, 7, 9. Those are now going to be my x coordinates, and my y coordinates are now going to be the -4, -2, 0, and 2. If we were to plot this on a graph, you could see they're going to be a reflection of each other over the line y equals x. We're going to get into that in a second. But so now on my new information, now my domain is the 3, 5, 7, 9, which should be the range of the original. And the range is now the -4, -2, 0, 2. So they literally just trade places in the table. That's it. Just flip them. This is actually not too bad to do on a graph either. So what we're going to do in the example underneath here, we're just going to do this on a graph. All right, now, easiest way I can tell you to do this probably is actually go to the graph and like try to pick yourself maybe a couple of points here that go right through a corner. I have about 5 points I could grab there that go right through the corner. And I'm just going to write down the domain real quick. Now, domain and range we wouldn't list here because we have a connected graph. So all these points are connected. I don't have just specific points that I would list. So we'll have like a little interval. So your domain for any parabola, one side goes left forever, one side goes right forever. So the domain should just be -infinity to infinity. Now, the range, I'm not touching any part of that parabola until I get to what y value? 1. So then I would have a bracket here, and the rest of the graph goes up forever, yes? So just 1 to infinity. Okay, now, you don't have to write this out. I'm just going to do this on my paper real quick. I'm going to write down these points that I have here. So I have the point, looks like -6, 9. I have the point -4, 3. The vertex is at -2, 1. I have a point at 0, 3. And then I have a point, looks like 2, 9. All right, so all I have to do to find the inverse is literally just flip the coordinates. So that first one, the inverse point would be 9, -6. The second point I wrote down would be 3, -4. Then it would be 1, -2. We're just switching the x and y coordinates places is all I'm doing. And I'm going to come over to the graph and plot these points best I can. The 9 is like all the way to the edge of the graph. Okay, and I don't know how well you guys, but this should make like a sideways parabola here. So I'm just kind of turning to the side, but it should be like a sideways U shape. That would be the inverse. And you absolutely don't have to draw this on your paper, but I'm going to draw it on mine real quick so you can see it. Anytime you have inverses, they're a reflection over the line y equals x, which y equals x would just start at 0, 0, just go up 1 over 1. It's like a perfect diagonal right through the graph here. So I'm just graphing y equals x. They should be a reflection. Like if I drew this perfectly, if I folded that graph in half on that diagonal line, those two parabolas would match up. It's just this is a parabola. This is actually, I don't know if you guys know this, this is a square root. So the original, right, the parabola we started out with, that is a function for sure. When I graphed its inverse, though, that now does not pass the vertical line test. So just because you have a function originally doesn't mean the inverse automatically is a function. Actually, it's not there because it would fail the vertical line test. You can write that if you want to. Touches more than 1 point. If I would draw a vertical line, any vertical line across that one I drew in purple there, fails the vertical line test. So it's not a function. All right, now, the domain and range, just for this purple graph I did here, should be flipped from this. So just to check, if you did the domain, just this purple graph, you don't touch any part of that graph till you get to the x value, and that is 1. and then the rest of the graph goes to the right forever. So that's going to infinity. So these two, the range of the original should be the domain of the inverse. And I know this is a little harder to see, but your range, this goes really gradually. This would go up forever. This would go down forever. So the range is negative infinity to infinity, which should be flipped from the domain of the original. They should be this, the domain of the original is the range of the inverse. Range of the original is the domain of the inverse. Does anybody have a question? Okay. Now, the one I've got here, and there's like a weird space, but this is just a log function. And let me see if I can get this on the screen. Now, I'm going to draw like a tiny little line here. This is a log function. And remember, it has a vertical asymptote. It's been a minute since we've done one like this, but it would get really close to that, never touch it, never go over it. The reason for that, we can't take the log of a negative number. I don't give you the equation for this or anything. We could figure it out, but we're not going to for the moment. We're just going to try and see if we can graph this. But you don't actually touch this -1. This x is -1. So the domain here, when you do the domain for the original, you don't touch this till you hop over that line. You have a parenthesis instead of a bracket. We go from -1 and then it goes to the right forever. So it's going to cover all these x values from -1 to infinity. For the equation, must be if we plug in something smaller than -1, we'd be taking the log of a negative number. Now, the range for log function, they're all the same. This would get really close to this asymptote. This goes down forever. This goes really slowly, but this would gradually go up forever. So the range for any log function should be negative infinity to infinity. Now, this does not become vertical. This gets closer and closer here, but it doesn't touch it, doesn't go over it. So this is a function. It would pass the vertical line test. That little curve does not ever become vertical. It gets really close, but not quite. So that is a function. It would pass the vertical line test. And then I would do the same thing we just did on the last graph to grab the inverse. So I'm just going to grab a couple of points here and see if I can get, let's see, looks like I'm going through 0, 0 as one of the points. And then I have the point, looks like 3, 1. And I don't actually touch this point, but I'm going to use it. I'm not actually touching this point, but it looks like it gets really close to -1, -2, just to help me do the asymptote on the other side. I'm putting a little star next to that because I don't actually touch that point. I'm just going to kind of draw a dot there. All right, so if I do the inverse, we would just flip. Now, if 0, 0 is a point, it would still be a point, because if I flip those, it would stay exactly the same. The 3, 1, we would flip, and that would become 1, 3. And then, again, this point is not actually on the graph, but this will help us get our asymptote. This would be -2, -1 when I flip those points. So the 0, 0 would stay. The 1, 3 would be right here. And the -2, -1. I'm just going to kind of lightly draw a dot there. All right, now this guy, if you draw it, I'm going to get really close. Let me grab a different color here. This is going to be my asymptote here at -1. So we're going to get really close to this, but never touch, never go over. The inverse here, this is actually an exponential. It'll be exponential growth in this particular instance. It's going to get really close to that. I don't actually touch that point, -2, -1, but we're going to, that's the best way I can get you to the asymptote there. It's still a reflection over that line y equals x. Now, the domain here, this guy that I kind of just did in my orange color. Left forever, this goes up really fast, but it would go to the right forever. So the domain should be -infinity to infinity, which is going to match the range of the original. And then the range of the original, or the domain of the original should match the range of the inverse. So you guys see, I wouldn't touch any part of this graph till I hopped over that -1, and then it goes up forever to infinity. Now, exponential and logs, they're both functions, so that would pass the vertical line test. Nothing's going to restrict that there. Does anybody have a question? Okay. Now, the rest of this is literally just going to be algebra. So I'm going to give you an equation, and I have different, kind of like a different thing for each one. So the first one is just, yeah, go ahead. The first one is just a line, All right, so if you have an equation, just remember, totally legal, just put a y over the f of x. That's the easiest thing. And I put that under each equation just to show you can do that. The process for this is the same as the table or the graph. We're going to switch x and y. We're just going to do it with an equation instead of points on a graph. So if I switch these guys up, I would just write x equals 4/5 y minus 8. So the original, this is a line. The inverse will also be a line. The original line and its inverse, if you have a line, the inverse is always also a line. Now, the key is you want to get y by itself on one side. So what would I do first if I was trying to get y alone? After I switch x and y, like what would you do first algebraically? What do you think? For sure. All right, let's move this 8. All right, now, I'd have x plus 8 equals 4/5 times y. There's a couple ways you could do this. Does anybody have a recommendation? Like, what would you do next if you're trying to get y alone? Okay, so let's multiply by 5. We'll get that out of the denominator. When you do it on this left side here, you're just going to have to do a little distributive property. So we're going to end up with 5x plus 40. And then over here, you would still have the 4 with the y. Because when I multiply 4/5 by 5, it's going to cancel out the bottom of that only. Now, to get y alone, I'm just going to do one more step. We're just going to divide everybody by 4. And because this is aligned, what I'm going to do here, I'm going to write y equals first. Now, the 5/4, I would just leave that as 5/4 x, right? Because that's just going to be your slope. And then 40 divided by 4 is 10. So this would be the inverse. And I'm not going to be super picky about it, but if you want to go back and replace that y with the f inverse of x, that notation, you can do that. I just want you guys to be familiar with it. Like when I work with these, I usually use x and y, but just so you can see it, that inverse notation would be the same thing. So if you have a line, this inverse, this is also a line. All right, now, my next option here, we got a quadratic. So this is f of x, x squared plus 6. I know it's quadratic because it has an x squared. All I did was replace the f of x with y underneath that, so you can see. The process for this, you switch x and y. So I would write x equals y squared plus 6. Now, to get the inverse, you got to get y by itself on one side. So if I have x equals y squared plus 6, what would you guys do first there if you're trying to get y alone? Try to get y by itself on one side. What would you do? What do you think? Let's move the 6. Okay. And so I'd have x minus 6 equals y squared. So the original was a quadratic, so a parabola. What do I do to get rid of the squared? Square root. Okay, so the inverse of any quadratic is going to be a square root. Now, remember, this, when I introduce the square root into the problem, I have to put that plus and minus symbol. So, and actually what I'm going to do, the square root of y squared would just be y. I'm going to write the y on the left side there. But what the deal is with that, if we were to put this on a graph, the plus, this would be like the square root of x minus 6 would be the top half. And then the bottom half of that sideways, like we graph this on the front, this would be negative x minus 6 under the square root. So the plus and minus, that's how it works. But that's what causes that to fail the vertical line test and not be a function. when we were working with radicals and graphing these, we restricted that. So we either had the top half or the bottom half. But if we're doing inverses here, it should have both parts, and it does not pass the vertical line test. But anytime you have a quadratic, the inverse should be a square root. All right, now I've got underneath here, it's been a minute, but this is a cube root function. All right, so I have y equals cube root, and you have the x plus 7 is all under the cube root. You technically don't need those parentheses. I was just trying to really define that the 7 is under the cube root with the x there, and the negative 10 is to the outside. So I replaced f of x with y, and then to get this in function notation, we could do that at the end if we want to go back, but we don't have to. I'm going to switch x and y to find the inverse here. So then under the square or cube root, sorry, we'd have y plus 7, we'd have the minus 10 on the outside. What would you do there first if you were trying to get y alone? Add 10. All right. So I have x plus 10 equals cube root of y plus 7. Can I subtract the 7 out from underneath the cube? No, you cannot do that. So how do I get rid of a cube root? Cube, you're going to take both sides to cancel, to cancel out a square root, we would square it. So to cancel out a cube root, you're going to take both sides to the third power. And as I do that, I'm just going to really quickly go back up here to the directions to tell you, it says leave in factored form, don't FOIL. So I mean, you do not need to do x plus 10 and multiply that out 3 times. We're just going to leave it in factored form. All right, when I do that, we would have just leave it in the parentheses, x plus 10 to the third. Now, the third root and third power cancel each other out, so we'd have y plus 7. The only other thing we would do real quick to get y totally alone is subtract the 7. It would just be outside those little parentheses. So I'm just going to go ahead and write y first, and then x plus 10 cubed, and the minus 7 would be outside of this. This is a cubic function if we were to graph this, which we're not going to here. But a cube root, the inverse is to have a third power. If you have a square root, the inverse is to have a second power. And then the last one I have here, this guy's an exponential function, the original. So I have 1/2 times 4 to the x. We're going to switch x and y here. So I'm going to jot down x equals 1/2 times 4 to the y power. It's been a minute since we've done this. I'm going to try and get y alone. Does anybody know what I should do first? Multiply by 2. Don't multiply the 1/2 and the 4 together. In your order of operations, you'd have to take care of that exponent first. So do not multiply these together. I'm going to actually get rid of the 1/2, and I'm going to do that, just multiply both sides by 2. So if you take 2 times 1/2, it would just become 1. So this would become 2x equals 4 to the y power. Okay, does anybody know how to get that y, or remember how to get that y out of being an exponent? You got to use the log, exactly. Okay, so if you guys, it's been a long time since we've done this. So the base of the exponent, I'm going to drag this over to the other side. When I drag that down, you're going to put a log. So the base of the exponent becomes the little subscript for the log. So it'd be log base 4. You just keep the 2x right where it's at, and then the y would be down on the level with the rest of the question. Now, probably if it was me, I would probably write the y first, but this would be the log base 4 of 2x, and that would actually be my inverse. So anytime you have an exponential, the inverse should have a log in it when you write the equation.